Assalamualaikum and good morning. My name is Nurul Nabila Izzaty binti Ahmad Zamri. I am from 4 BEI section 1/1. So I'll share my content. Okay. For the section 1, please tick and provide a correct picture. This is a list that is containing the few apparatus for HIPOD test. So we're gonna use this in the bin. Okay. So the correct apparatus the correct apparatus that involved in the HIPOD test is including one test transformers, one measuring capacitors, measuring resistor, grounding switch, discharge rod, top electrode, insulating support, sphere gap, drive for sphere gap, connection rod, connection cup, floor pedestal, space bar, and secondary part for CM. For the next question, which is section 2, assemble a AC generation and measurement system. I have to draw the electrical schematic diagram for AC generation. So for AC generation and measurement. So firstly, open the pane. New. Okay. We have to take a look at too big. This is this is general general what we call it, general circuit that involved in AC generation and measurement. So they included a high voltage transformer, a conductor, and a voltage divider apparatus. So our firstly, we need to open the manual kit first to get this. Firstly, we need the transformer, the high voltage transformer, which is this one. Okay, this one. Copy. Just need one. Okay. I don't really know how to use this pen. So, okay. So this is this is a transformer symbol. This is from a point, from a terminal, assuming this is the positive terminal and this is the negative terminal. Next is involved is a conductor. Next is I can't really see it. So this one, this is a conductor. We have a few conductors that we use, which are capacitors, resistors. Okay, here are they. Okay, so we can use this is number 1, which is a transformer. So I think I need to draw the real schematic here. So this is the supply from the frequency converter itself, positive and negative terminal. So it will supply to a transformer. This is the transformer, and we will connect the transformer to the secondary unit through a conductor. So the conductor we use, like the lab 2, is a steel rod, a pure steel rod that we use to connect the large high voltage transformer with the switching, the secondary part of the secondary part unit. So the secondary part unit consists of top electrode, which is this one, top electrode. How can yes, we save this as let us one for us to easy. Easy access later. We save it to the high voltage folder. Like this. Okay. We make it bigger so we can access to it. You can put more things in it. So a top electrode is let me show some pictures that I have. Is it? So we also use a measuring capacitor, which is this one, a 100 picofarad. So I will okay, this top electrode goes on top of the measuring cylinder, measuring capacitor itself. So this is the terminal, the symbol for capacitor. I think I need to open. Okay, so we continue here. The the conductor connected to a, this is the terminal, this is the terminal, conductor connected to a capacitor and connected to a secondary unit capacitor, which is this one. It has approximately 19 capacitor connected in series, like the Zener diode. We use this one connecting cup at the top of the measuring capacitor before the top electrode, and the flow pedestal is located at the bottom of this one here. The flow pedestal located here. Flow pedestal located here. Okay, flow pedestal here, and what the other one is connecting cup. The connecting cup is here. The connecting cup is here. And this is the top electrode. This is the measuring capacitor. This is a measuring capacitor. Top electrode, and then this is the measuring capacitor, and it will connected to this one. This one, the secondary part. Secondary part. Okay, secondary part. So the inner of the secondary part is look like this one, like this, and I said, okay. Look like this. Okay. Copy, paste it here. Okay. Okay. This one is a secondary unit of the secondary capacitor. So it connected in series. One capacitor, two capacitor, three capacitor. Ni capacitor 1, capacitor 2, capacitor 3 until the 19 capacitor. So it connected in series like the Zener diode. Connected in series. Connected in series. The secondary unit or secondary capacitor. Okay. So this one this one is connected in here. And oh sorry, I didn't draw the grounding. So okay, grounding. So grounding here. Okay. And lastly, sorry. Conductor, the voltage divided. Okay. Switching spark gap. This is the switching spark gap. Switching spark gap. Okay. We look at switching spark gap. Okay. This is a switching spark gap. Switching spark gap. So the okay. All right. And okay. Secondary unit for AC must be terminated at VM1 or frequency converter. All right. Sorry, I forgot. Okay. So the secondary unit is we will connect it. There will be a connection using the auxiliary cable. Using the auxiliary cable connected to the directly to the frequency converter, to the frequency converter panel, which is this one. frequency converter panel, the outside panel of it, this one. Okay. So the panel I mentioned about is this one, this panel. We will connect it. The here is the grounding, the copper strip. We will connected the strip here, and the upper side is I cannot remember. But we will connect it, the secondary unit here, connected the auxiliary cable to somewhere here, and we will operate it through Picoscope software. Picoscope software directly from the control room. So I think we're done for section 2, and we will move to section 3, safety and rules. So we have to watch the video. I've opened it. The video. Okay. Firstly, as we can see, the cable here is not neatly organized. So the safety issue here is you might be tripped or step on one of the cables that is unorganized here, this part, and the copper strip for the grounding itself. Okay, we continue. Okay, we back to here. As you can see, the gate of the cage itself is not properly closed. It's not closed at all. So we need to close both of these gate. Close both of these gate after entering the cage, and before starting to operate any of the instrument inside. Okay. Uh, uh, I I've already explained this one before. Uh, it's okay. I mention it again. As we can see, the cables are all over the place. It is not neat, and we can be tripped or step on the cables and fell, and and it will um it will it we might fail and hurt. Okay, so um we need, so you can see the copper strip is not properly organized. This cable around here to okay. And the question asks us to give a the suggestion about the proper strategy for the layout inside the cage itself. So I think we can do it at here. Okay, let's say this is our cage. Here is the what we call it, the gate of the cage. So the gate must be closed after entering the cage. Next is we for the component. Okay, we put here will be the grounding that mounted to the building. Here is the grounding. Sorry, we will change it to green. Okay. So next, oh sorry, change. Okay, next is we will put the frequency converter here. The FC. Oh, sorry. FC. Okay, FC. This is the thing mounted to the wall. Here will be the transformer. We label it X, the high voltage transformer, HVTX. HV is for high voltage, TX is for transformer, and the measuring capacitor here, along with the top electrode, the floor pedestal, the connecting cup, and the switching of the earthing itself. And here will be the other one. Sorry. I forgot what to call this one. Wait, search for it. So, that green box. Wait. This one. Drive for the spear gap. This one. It, this one, and then the cable should be neatly organized here so we won't trip on it. And the secondary unit. So the secondary capacitor or unit will be here. So I think that's all. So I think that's all. Thank you.